Hey guys, this is Geocentrism Explanation again, coming at you from down under. So this video title is a little bit misleading. I'm not going to prove the flat earth. Anyone should know now that proving something to 100% certainty is impossible. You know, even modern day scientists will tell you you can only prove something to 99.9% accuracy. But what we can do as a community is we can keep building up the evidence. We're going to just keep building up the evidence until we've just got this mountain of quality, thorough, too hard to look past evidence on the side for the flat earth, whereas these globers are going to have like this just shonky, bodgy pseudoscience, really hard to explain, really hard to understand bullshit that they call evidence. So hopefully this helps the flat earth community a little bit more, and this will give you guys a little bit more evidence for the collectible tin, to throw out at any of these globalist fuckwits. Okay, so I was talking to a guy and he said to me, if the earth was flat, we should be able to see Mount Everest in an airplane from anywhere in the world. And I'm thinking in my head, this can't be correct, because I mean the human eye has its limited capacities. You can't see fucking 200,000. You can't see like 2,000 miles away if you're in a plane. There's no way. Think about that logically. You can't see 2,000 miles. It would just be ridiculous. So I said, look, that wouldn't be the case because the human eye can't see that far. And his response was, you can see stars which are thousands of light years away. And I said, I thought to myself, okay, this is, I can see your logic here, but then why is it that when I look across the horizon, I can't see a ship that's, say, 20 kilometers away? If it's poor atmospheric conditions, then I'm lucky to see a ship maybe 3 kilometers away. If it's a clear, beautiful, clear day, I might get 20 kilometers, 30 kilometers max out of my vision. And his response, which I knew what it was going to be, is, well, duh, there's a curve. So once the boat travels, 20 kilometers away, it disappears below the horizon. You can no longer see it, unless, of course, you were to propel yourself upwards, or if you were to walk a little bit more forward and kind of like start curving around the ball yourself. So now this is going to be my attempt at debunking what he is saying. Defalsifying, I think the scientific term is. I'm going to say why his hypothesis is flawed, and that hypothesis is the ship is disappearing due to a curvature on the horizon. So the first thing we're going to do, if we're going to try and debunk or defalsify somebody's hypothesis, is we need to make sure we understand exactly what they are talking about. I find it so frustrating when we have these globe earthers telling us why we're wrong, but like they haven't actually like listened or fully comprehended what we have said. So by trying to debunk us, they're not really addressing the points that we made, and then they kind of sound a little bit ignorant. So like, for an example, all these people keep saying the earth can't be flat because you'll fall off the edge. Well, you're not debunking our hypothesis, because in our hypothesis of a flat earth, we've explained already why you wouldn't fall off the edge. So first we have to understand how much is the earth curving, according to the people that say ships disappearing from our line of sight because of the curvature. And the way I found that was, I just did a quick Google search, and it's funny actually, I got a few different formulas, but I'll put them up on the screen now, so we can all agree that the general consensus is roughly 8 inches per mile. So every time you go a mile, the earth is going to drop roughly 8 inches. So even looking for this formula, I felt a little bit strange because Google, that image on the screen now is just from Google. If you punch in how much is the Earth curve, but then a few other websites say that it's the 8 inches per the first mile, and then after the first mile, you have to square it. So like it means it curves a lot more faster because you're multiplying the number by itself. Um, but in either way, we can run the experiment that I'm going to do with both formulas. And no matter what formula we use, we're still going to debunk the hypothesis of ships are disappearing due to a horizon curve. So let's get to it. So I'm going to use the old lighthouse on the horizon example to debunk this. Now it's kind of funny because this was in my physics textbooks all through high school. I did 1 year of physics at university for my first year, and this was always used to back the flat Earth, and now I'm going to use it to debunk it. So first we have to understand that our Earth is curving 8 inches per every mile. So we will be able to get a calculated curvature given a certain distance. So let's use an example here. Let's say that we are on a boat and we are 40 miles out to sea. Now we have to take into consideration the height of the lighthouse. So with a quick Google search, you can bring up the height of the lighthouse, and it stands 180 feet high, which this is taking into consideration also the sea level incline from, obviously, you get from a small island, which isn't much, but it is 180 feet high. That's the point. Now, if we are on a ship 40 miles away, the lighthouse, going off the Google formula of 8 inches per mile, we're not even squaring here, the lighthouse should be 996 feet below our line of sight, meaning we should not be able to see it. Unless, for some magical reason, our eyes have the ability to bend 996 feet around a ball, which they don't. If something's underneath you, you cannot see it. It's that simple. Now, this is the tip of the lighthouse. It is 996 feet below our sight. Not the base, but the tip. So the base would be an extra 180 feet below that. So, you know, we're talking now nearly 1,200 feet. So I'm pretty sure you can guess where I'm going with this. And where I'm going with this is that ships can see the Isle of Wight Lighthouse from 42 miles away, which is an extra 2 miles to what we just calculated. That shouldn't be possible. We are not seeing the lighthouse disappear due to curvature if we are using the mathematics given to us by Google and NASA. There is something else here at play. Now, from my results, we can draw two conclusions. Conclusion one is that the Earth is a lot bigger than what they're telling us, and therefore the curvature is further away than what we should see. So the formula would be something more like, you know, maybe 20 miles. Every 20 miles we're dropping 8 inches. That's one conclusion. But if we are going to accept that conclusion, well, then that can be debunked pretty quickly, because we know the rough distances between each continent. We know the size of continents. We've circumnavigated the globe. Haha, hear that? We've circumnavigated the globe. What I mean to say is we've circumnavigated a flat plane, which is possible if you follow a bearing of east or west and just keep going. You will eventually come back to where you started from. So it's kind of, you can't say that the globe is bigger than what it is. Now, the second conclusion we can draw from this data is that something else is at play. It's not the curvature of the Earth causing things to disappear, because if it was the curvature of the Earth, it would be a constant. we would know 100% that when you cross the 20-21 mile mark, that you would drop below sight. But the thing is, we can see things 42 miles away, and there has been reports of things being seen from nearly 100 miles away. So there's another factor at play here. Now, my hypothesis is that it is atmospheric conditions and the limitations of the human eye. Meaning, we just can't see that far. We can see, 40 miles on a clear day, and that's about it. So, if we do accept that, and we say the human eye is limited, and atmospheric conditions can make it difficult to see, well then, two things come into play. First of all, how do we see the stars if they're supposedly light years away? Well, I would turn around and tell you that they're closer than that. They're going to have to be within our range of sight. And also, the atmosphere is going to not extend for infinity. Once there's no atmosphere anymore, maybe we can see longer. I don't know personally because I haven't left the atmosphere myself. I've only been able to use my eyes within the atmosphere, and I've also done scuba diving, so I've used my eyes under water, and I know my visibility and perception is a lot less underwater, so I would assume that once I leave the atmosphere, if it is even possible, that we would be able to see a lot further outside of an atmosphere. But in saying that, that is how I've debunked that hypothesis, and I would love for anyone now to step up to the plate and tell me why I'm wrong. Don't come at me, don't abuse me and tell me I need to have a basic science course. I understand diffraction of the atmosphere and how light bends, but this lighthouse was seen in the daytime. There was no light on it, so it wasn't the fact that light was bending. It was visible from 40 miles away in the day. So we're not going to go into light bending and atmospheric diffraction because that's just a load of hogwash anyway. What I want somebody to do is don't insult me, don't tell me that I need a basic science lesson. Give me a solid and easy to understand explanation of why we can see things if by mathematical law they should be below the horizon. I hope this helps you guys in the battle for truth, and as always, have a fantastic day. God bless. Shalom. Hashim Pradesh. Hare Krishna. Thank you for your time in watching this video. Please like and subscribe. I'll be pumping out more content as much as I can. I'm off to go train now. Keep the mind healthy, the body healthy, and get ready for the new world order, guys. We're gonna win.